to restate what I said, we're going to have, I expect you to go through on this website, Coursera, data science, math skills, look that up. The name of the school, you can also put that in the search, is Duke. And the first week, you're supposed to go through all of the first week assignments, and then I'll give you a quiz on that next week. Okay? And just to say it again, you definitely don't have to pay on the website. You might have to figure out how it works, but you definitely do not have to pay. Okay, so let's go to where we are now. And so we need to do, where happened to the log? Derivatives of logs. Okay. Well, oh, I thought we had something about logs here. Let's see. Logs. Just derivatives of logs. Okay. All right, well, we need to talk about logs before we can talk about derivatives of logs. So let me go to resources, which hopefully you also have access to resources. And I'll go to download these PowerPoints. I hope you have that same access. Otherwise you have to look in the book. And so let's take a look at that. I think it's probably, let's see, where is it? Excuse me, but I have to check through this. Well, actually, let's stop. Let's take a look at this because I wanted to do this also. Okay, marginal analysis. So let's do this. I think we skipped over this. So we have considered linear cost functions of the form C of x equals mx plus b. Right? This is cost, and this is what's called a linear function. Right? It's a straight line. You have mx plus b, where c is the total cost, x is the number of items, and m and b are constants. The slope m is the marginal cost. It measures the cost of one more item. Okay, everyone understand that? Okay. Notice that the derivative of this function is just m, right? Okay, in other words, for a linear cost function, the marginal cost is the derivative of the cost function. All right. A cost function C specifies the total cost as a function of the number of, okay, we certainly know about that. The marginal cost function is the derivative C prime. Okay, let's look at an example. Okay, so here's a cost function. So what is the marginal cost? Here's the cost function. What's the marginal cost? Just the derivative of that, which is what? 400. Okay, here's another one. Suppose that the cost is given like this. This is the cost for manufacturing portable music players, where x is the number of music players. Find the marginal cost function and use it to estimate the cost of that. Okay, so how do I find the marginal cost function? The derivative. So what is the derivative of this? 20 minus 0.0002x, right? Okay. So what does the marginal cost tell you? The cost of producing one item, right? But But what's the derivative here again? Or maybe I can write it. Let's see. What's the derivative? 20. Why doesn't this work? It's supposed to work. No, it's not white on white. Let's see. Is that right? Ink color. It's red. No, it's red. No, white on white. I don't know why it doesn't work. It's supposed to work. Try it once more. Usually it works. Pen, color. That's so strange. Okay, let me try it here. So weird. What is that? Why does that work, but this doesn't work? Ridiculous. Okay, maybe I have to do it really big. Maybe that's the issue. Let me try it again. Let me try it with really big writing. Okay, what's the derivative? Okay, 20 minus what? 0.000. No. What? I have no idea what it says. Anybody know what it's happening? What? No, it's not gonna help. But okay, I'll try it. Okay, this was 11.2. I have no idea why. Okay. 20 minus 1. Go. Junk. Okay, anyway, so what's the derivative? 20 minus 0.0002x, right? And that tells you the cost of producing the item, right? So that tells you that the cost depends on x, right? Because it was 0.0002x, right? So the cost is not constant, right? Whereas in the last example it was, right? So because this is not linear, then the marginal cost is not constant. That means the cost of producing one more element is different depending on whether you're producing the 10th element or the 100th element. Okay? So if it's the 10th element, you'll put 10 into 0.0002x. And if it's the 100th, you'll put 100 in there. So you're going to get different marginal costs. Okay? So there's the marginal cost function. The units of the costs are dollars per unit of x, because anyway, thus C prime is measured in dollars per music player. The cost of the 50,001st music player means you put 50,001 into here. Okay? And that would give you the cost of that. Now what does that mean, the cost of the 50,001? Let's say, what's the cost function again? $150, I'm just going to write it like this, plus 20, it's not the same, but I don't want to write all that, plus 0.0001x squared. Okay, that's the marginal, that's the cost function, right? So let's say I want to know what's the cost of the 11th item. So if I want to know that, how do I figure that? What does that mean? The cost of the 11th item. So chalk here. What does that mean, the cost of the 11th item? No. Okay, so he said you put in 11 into here, and that'll give you the cost of the 11th item. That's not what this tells me. That would tell me the cost of producing a total of 11 items, not the 11th item. Okay, this is a total cost, but I want the cost of the 11th one. Now you can see already that this cost function is not linear because there's an x squared there. The total cost function is not linear, right? Now, did I forget a minus sign? Yeah. Right? So the coefficient of the x squared is negative, right? So that means it's going to look something like this. Like an inverted parabola. Okay, because the coefficient is negative. So well, maybe. That seems a little bit odd, right? That tells me the total cost is decreasing, which doesn't seem to make sense. But I'm not sure. I'm pretty sure that that's what it looks like. Okay, but anyway, it's a parabola. It's either like this or like that, but it's like that. Okay, so it doesn't exactly make sense, I guess. In reality. Maybe up to this point it makes sense. But after this, it doesn't make sense anymore. Okay, but anyway, what do I mean by the cost of the 11th item? So this is what we mean. The cost of, first of all, what does that mean? That's the cost of producing 11, total cost of all 11. But with this, well, what does this mean? That's the total cost of producing 10. So what's this? Minus this. And that's the cost of the 11th item, right? Okay, that's literally the cost of the 11th item. Now this thing, they said, is also the cost of producing the 11th item. Right? That's what they said on the screen. But that's not completely true. It's very, very, very close, but it's not exact. This is exact. This is the definition. Right? This is what we mean by producing the 11th item. This is just an approximation to that. Okay, and you can see that it's an approximation because, let's say, it would look like that. Okay, and let's say this is, instead of the 11th, let's say this is 10,001. Okay, 10,001. So what does the derivative tell me? It tells me the slope, right? So if I do the derivative at 10,001, that's supposed to tell me the marginal cost, right? According to what they said. But it also tells me the slope of this line, right? Right? It tells the slope of that, right? Now, if this was just 11, then 10 might be here, right? If that was 11, then 10 might be something like there. So if I wanted to know the actual cost of the 11th item, what would I do? I would take the height here and the height here, and I'd subtract. So I'd have that length there would be the actual cost of the 11th item, right? this line, but this length is exactly the slope of the tangent line, or pretty close, sorry. It's, here's the, sorry, not exactly. What's the slope of the tangent line? It's going to be, here, go 1 unit. Why is it not exactly a second? Go here, go 1 unit. Well, actually the slope of the tangent line is going to be here. So it's not going to be quite that long. Because what do I mean by the slope of the tangent line? I mean if I go 1 unit over, I 1 unit over, I go 1 unit up. I'm sorry, how much do I go up, right? That's what I mean by the slope, right? If I go 1 unit over, how much do I move up, right? That's the slope of the tangent line. And that's not exactly the same as what we just said. So what we just said, because this is a little bit longer than that. If I go 1 unit from here, and then I go up, this length, which is actually the real marginal cost is that length, right? Right? That's, nothing's working today. Okay, so the real marginal cost is, if I go from here, it's this height minus this height, so that's this length, right? That's the real marginal cost. But the slope is going to be from here to here. So this part is not in there, right there, that part. Okay, so there's a little bit of a difference between the slope and the true marginal cost, right? This little red part. That's going to be the this whole thing is the true marginal cost, but the slope is just this part here. Okay? Right? So it's not exactly the same. But if this isn't 10, but rather this is 10,001, 10,000, and this is 10,001, right? Then actually these 2 points are super close to each other in this kind of scale. So it's like moving these really, really close to each other. Then the difference between the yellow and the red is going to be tiny, tiny, tiny amount. Okay? So the marginal cost and the true marginal cost and the derivative are going to be basically the same. Okay? They're going to be very, very close. Okay? So we can just use the derivative as a substitute for the marginal cost. Okay? So if we try that with this, you'll see that it's true. So if you put in, what did they ask us? 50,001. If you put in 50,000 and 50,001 into the cost function, like that, you're going to get the true marginal cost. And if you calculate that, and you calculate the derivative and put in 50,001, you won't be able to see a difference. Like the difference will be like 0.0000 pennies. Right? It'll be virtually nothing. We don't want to do this calculation, right? But you would see that it's almost exactly the same number. Okay, so the C prime is a reasonably good approximation for the actual marginal cost. Okay? The difference, like I said, when you you know, when you're talking about 10,000 and 10,001, then this point is really going to be right there. So the difference is going to be virtually nothing in terms of this length and the other length. Okay? So that's what we mean by, so that's why we can use the derivative as the approximation for the marginal cost. Okay, any questions about that? Okay, thus we need to know the rate at which the total cost rises as we increase production. The rate of change is measured by the derivative of the marginal cost which we just computed. So if we put in 50,000 in here, we get this calculation. We get this calculation, which turns out to be $10 per music player. In other words, we estimate that the 50,000 in first music player will cost approximately $10. Okay? We put 50,000 into the C prime function. Okay, now you might say, well, should I put in 50,000 or should I put in 50,001? But basically, you're going to get the same thing. Okay? Because of this factor here. Okay, so it's not going to make much difference. And I'm not sure technically which the economists will decide is the proper number to put in. I think, you know, you could argue either way.